Hey folks, welcome to my channel Number Pen. We have the problem on your screen. Limit x tending to infinity. We have x squared minus 2x plus 1 divided by x squared minus 4x plus 2 and this entire expression to the power x, right? So we see two components in this particular problem, right? One is a rational function component and then you have an exponent to the rational function. So the rational function is your function of the type p of x divided by q of x, which is nothing but your x square minus 2x plus 1 divided by x square minus 4x plus 2. And you have got x in the power component, right? In the as an exponential component. So let's approach this problem initially in a manner that we use to approach a plain rational function, right? So we've got a numerator of the degree 2, we've got a denominator of the degree 2. So let's divide the numerator and the denominator by an x square, and we will have to do it inside the bracket, right? Which means we'll have to take it inside the whole power of x, and let's see what do we get. That's the approach which we normally take to solve problems of rational functions whenever we want to find limits of rational functions. So let's do that. Here we will have to do a divide by x square, right? So let's do that division and rewrite this expression, right? And what do we get? When I divide the numerator and the denominator by x square, all that I get out here is this expression divided by an x square, right? And then I take go to my denominator. I have a very similar expression in the denominator. So let's first bracket the denominator and then we will go about writing this expression. So we have x squared minus 4x plus 2 in the denominator, which is what we will bring in. And let's keep x squared as well here, right? And then let me raise it to the power x, right? And I do this for the denominator as well. So there we have our revised expression, right? So we have x square minus 2x plus 1 divided by x square, the whole power x in the numerator. And we have got x square minus 4x plus 2 divided by x square, the whole power x in the denominator, right? I can further rewrite this expression like this, the way I'm going to write it now. Let me again put it in the same very similar format. So what happens when I further rewrite this, right? My x square can be rewritten like this, right? 1 minus, and then I open bracket, and what do we get here? I have it as 2x minus 1, right? And what do I have here? I can write this further as 2x minus 1 divided by x square, and this entire expression we bracket it and raise it to the power x, right? Let's take a few seconds to see if we have done everything right. Yes, Or let us write it this way, right? Let's write it as 1 plus 1 minus 2x, right? And why am I doing this? I'm doing it simply because I'm trying to relate it to one of the formulas on the right side of your screen. And that's why I'm trying to re-express this as 1 plus something the whole power x, right? And when I rewrite the denominator in a very similar way, what do I get? Right? And there we have our expression, right? Let's take a minute to see if we have done everything right. So the numerator is 1 plus 1 minus 2x divided by x square, the whole power x, and the denominator is 1 plus 2 minus 4x divided by x square, the whole power x, right? We know that, now what I'm going to do is I'm going to try and connect this with one of the formulas that we have under exponents and limits, right? And if I look to my right, the immediate formula that I'll be able to connect this with is limit x tending to infinity 1 plus 1 by x, the whole of x, right? And or I can also use 1 plus x to the power 1 by x as x tends to 0, right? And why is that? Let's do something which we usually do in our previous problems, especially the ones which are slightly complicated. Let me adopt an LO for the first part of the expression, and let me adopt a green for the second part of the expression, right? And we're going to start off with the LO part. So let's take that out. And once we solve that, the green part becomes very simple, right? Because it's more or less very similar to what we are going to do with respect to the LO section in this particular problem. So let's rewrite this expression, limit extending to infinity, right? And I'm going to pick up only this expression, folks. So let's write this out. And we know that what is this expression? I'm just going to further bold this, right? When I rewrite this, uh, this is 1 minus 2x divided by x square, right? So, and when x tends to infinity, I know that I can rewrite this expression. When I write it like this, I realize that as x tends to infinity, this expression, which is 1 minus 2x by x square, actually tends to 0, right? So if I'm going to replace 1 minus 2x by x square as a y and rewrite this expression, then what do I get? All I get is, let's do that in the next step, right? If I do the substitution, let's assume this is equal to y. What do we get? As x tends to infinity, as x tends to infinity, your y will tend to 0, right? This is what we saw in the previous step. So if I want to rewrite this expression, um, how do I do that, right? So let me copy this again. Let me write it out here. So If I want to relate it to the formula on the right, which is 1 plus x the whole power 1 by x, right? Which is nothing but 1 plus. Folks, this is not a very simple problem, but I think once you understand how to approach these problems, they become a lot simpler. And the only thing that is required from us is to be very careful and not to make those silly mistakes in these steps, right? That's why I'm going a bit slow in this particular problem. And if I want to rewrite this of the format 1 plus x the whole power 1 by x, how do I do that? So we have a way of writing this, right? And this is where it gets a little clumsy, and you will have to bear with me. Let's this I can further rewrite this. Have 1 minus 2x comes in the denominator. All that we are doing is in the power component multiplying it by an x square by 1 minus 2x into 1 minus 2x divided by x square, which is nothing but a 1, right? So let me bracket this out, and then again I'll have to raise it to the power. And when I do it this time, remember I have my x with me, right? That's where we could possibly go wrong in these problems, right? So I have my 1 minus 2x divided by x square, right? And when I write my x square, I also have my x here, right? So let's not forget that. And because I have my x there, all that happens is I can use that x to cancel out the x square and convert it into a 1 minute. Let's do it like this, power, and then I have into x, right? Now I can cancel out one of the x's here, which means I can remove this, I can knock this off, and I can just leave this with an x, right? So now you see our expression does not change. All that we have done is 1 plus 1 minus 2x divided by x square, and raise it to the power x square by 1 minus 2x, and this entire expression raise it to the power 1 minus 2x by x, right? And so now, if we saw in the previous step that 1 minus 2x by x square tends to 0, and therefore x square by 1 minus 2x will tend to infinity, right? So what is this expression? Let me highlight it. And what is this expression? Let me use a different color altogether, different color now. This entire expression is of the format 1 plus this format, right? Where instead of x, I have 1 minus 2x by x square, right? So I know that as 1 minus 2x by x square tends to 0, this entire expression will tend to e, right? And if I'm going to treat these limits separately, right, maybe we can rewrite this in the next step here. If I do the substitution here, like what we did, right, 1 by x square minus 2 by x, if I'm going to assume that equals y, I can rewrite the limit like this, right? Y tends to 0, and we have the new expression as 1 plus y, the whole power 1 by y, right? And remember, we still have an expression again raised to the power of 1 by y to the power 1 by 1 plus y to the power 1 by y, right? So let's not forget that, by y, right? So this is one part, and I want you to take a close look at the other part of this expression, right? Which is this part, which is 1 minus 2x. Uh, Let me put another color to this so that it becomes a lot more easier to visualize this, right? Let me put a pink, right? So what is this expression? 1 minus x, 1 minus 2x divided by x, right? So let's bracket this, and when I rewrite this, I get 1 by x minus 2, right? And we know that in this expression, we have done this substitution only for the sake of simplicity. We do not have to replace the pink part, which is the exponential part, with a y component, right? Because we know that as uh, 1 minus 2x divided by x is nothing but 1 by x, 1 by x minus of 2 by 1, right? Which is nothing but 2. So let's call it 2, right? So we know that let's also have your comma extending to infinity, right? And remember, folks, the y is only for substitution, for you folks to actually relate it to the formula, which is 1 plus x the whole power 1 by x when x tends to 0, right? But otherwise, it's not necessary that you will have to represent everything in the form of y. It's solely for the purpose of understanding, right? So what happens to the exponential component here as x tends to 0? This component, let me go back and pick out my pink color, and this component, which is my, what do you call this, you can call it turquoise, right? What happens to this? So the first part of it is e, and the second part, which is the exponential part, tends to 1 by infinity minus 2, right? As x tends to infinity. So what happens to that? It's 0 minus 2, which is e to the power minus 2, right? So that's the answer for this particular question, this particular part 1 of this question, right? So let me call that as e to the power minus 2, right? And why is that? Because 1 by x is 1 by infinity, which is 0, and 0 minus 2 is nothing but it is minus 2, right? So that's the first part, and I hope you got a good grasp of what we are doing here in part 1. And I'm going to move on to part 2 right here. So let's pick out the green expression and let's write it. And you're not going to have the formulas for some time now, and that's okay, because by this time you would have memorized most of them. So I'm going to pull this out. I'm going to spend lesser time here because it's more or less very similar to the way we solved the earlier problem, right? Earlier part. So I've got extending to infinity, and I'm going to write this, copy this, and put this out here, right? So when I write this in a manner which is very similar to what I did earlier, all that I will get is 1 plus 2 minus 4x by x square, the whole power. And what do I do to put it in the format of 1 plus y to the power 1 by y? Is nothing but I call out this as The inverse of this, x square 2 minus 4x 4x, and this again I bracket it, and I raise it to the power. Now I'll have to multiply it. Remember, I have the x still. To compensate for what I did, I will have to multiply it by 2 minus 4x by x square. And when I still have my x, still have my x here above, I can use the x to cancel out 1x of this x square. So what do I get? I get this as x, right? So this is what we have as our revised expression. And like my previous problem, I'm not going to spend a lot of time here. My first part is nothing but of the format 1 plus y to the power 1 by y, right? And so call this as y. And when we rewrite this expression using y, we know that, what is 2 minus 4x by x square is nothing but 2 by x square minus 4 by x, right? And what does that tend to? That tends to 0, which is your y in this case. So my y tends to 0 and my x tends to infinity. I still retain it. And like we did in the previous problem, this is purely for simplifying the expression. I mean, the replacement of 2 minus 4x by x square is purely for simplifying the expression. And when I do this replacement, I get a y here. And what is my x square minus 2 by x square divided by 2 minus 4x is nothing but my 1 by y, right? So I do that. So let me write out my 1 by y, right? Right. And remember, I still have a component which I will write it now, but I'm going to write that in a slightly different way that will help us move ahead and solve this problem. So what is my 2 minus 4x divided by x, which is this part, right? Let me highlight it and let me call it again by a new color. What do I have? No, this is a very dark color. So let me pull out something light. Okay, this is not bad. So this is still 2 by x minus 4, right? 2 by x x minus 4. And as x tends to infinity, my 2 by x tends to 0. And so my second part of the exponent, right? When this entire expression, uh, which has 1 plus y to the power 1 by y tending to e, and the second part of the exponent, which is 2 by x minus 4 tending to minus 4, my entire expression, just like how we saw in the previous problem, will tend to e to the power 0 minus 4, which is nothing but minus 4, right? So 0 minus 4 power minus 4, right? So now we have solved for the numerator and we have solved for the denominator. So I'm going to go back and copy the problem, and so that we rewrite it we solve for the final answer. So we have the limit of the numerator, which is nothing but my e to the power minus 2. And we have a very similar thing done for the denominator as well, which is e to the power minus 4. And when I rewrite this, all that I get is e to the power minus 2 divided by e to the power minus 4, which is e square, right? So that's the final answer for this problem. I hope you found this video useful. Please do subscribe to my channel and support. Thank you.